Okay, ionic compounds. There are two types. So if you go back to the diagram, we started with this a few slides ago. When it's split it into ionic and covalent. Ionics, there's two types. There's binary and tertiary. Binary will have two elements. Tertiary will have three elements. These are made of ions, which I'll explain in a minute. You really can't memorize the names of the ionic compounds, but you can memorize their parts. We're going to go over the binary first and then the tertiary, and pay attention. Okay, pay attention to details. Do not use covalent methods to figure these out. Okay, now there's going to be a little bit of similarities to covalent, but these have a whole different way of learning their names and formulas. Okay, so don't do that. When I was learning this stuff a long time ago, I just thought they are all done the same way, and over the years I've learned that there's another way of doing this. All right, so let's get it. First, I want to go over some key things about the atom. So let's look at the makeup of an atom, and we'll spend more time with the makeup of atoms in the last 3 weeks of class, or the last third of class. Okay, depending on what semester I use this in. And so let's take a look at an element, and let's take a look at oxygen. Again, we sort of went over this already. Oxygen. So let's just look at the square. So this square is taken out of the periodic table. It's from the second row and the 16th column. Right, and oxygen is its name. Its atomic number is 8. This atomic symbol is O, and the average atomic mass is 15.999 atomic mass units, or AMUs. Okay. The atom is made out of 3 parts. Atoms are made out of 3 parts, except for hydrogen, which has usually only 2 parts. It has protons, neutrons, and electrons. All right. The mass of the protons, the mass is 1 atomic mass unit, 1 AMU, and has a positive electrical charge. Neutrons also have a mass of 1 AMU, but they have no charge, and electrons weigh a lot, have a mass way less, about 1/2000th of AMU, but it has a completely negative electrical charge. So protons and electrons have equal but an opposite electrical charges. We're not going to be worried about mass right now, or even neutrons. We're just going to really pretty much focus on protons and electrons and their charges. Key things is that the number of protons of an atom is invariant, means it never changes, and it's the atomic number. So here's the atomic number, and this also tells me how many protons it has. Okay, now the number of electrons and neutrons can vary. So oxygen, when it's all by itself, will usually have 8 electrons and a net electrical charge of 0. Okay, so atomic number, 8 protons, and usually 8 electrons, but that can change, and we'll see that in a minute. All right, ions. So ions are atoms that have more or less electrons than protons, and then we'll thus have a net electrical charge. Okay, so let's go over an example. For instance, oxygen can often be found with 2 extra electrons, and we're not worried. We don't have to know why or anything like that, and we'll talk about that in a few weeks. But if it has 2 extra electrons, it would have 10, because normally it just has 8, but sometimes it has 10. The number of protons doesn't change though, has 8. So there are, in this case, it has 10 negatives and 8 positives, so it has a net charge of 2 negative. And we would write down that as 2 minus. So we'd write out as O2 minus, and the 2 minus would be up in the corner. Right hand corner as a superscript. Negative ions are called anions. Okay, looks like anions, but it's anion. Alright, let's take a look at another example. Sodium can often be found missing 1 electron. So when it's neutral, it has 11 protons, 11 electrons. See that over here? There's the atomic number is 11. But in this case, when it loses 1 electron, now it has 10 electrons. Again, we don't really care right now why. So there's 10 negatives and 11 positives. So it has a net charge of 1 positive. Positive ions are called cations. Okay, and the key thing here is the reason why ions are formed is there's gain and loss of electrons, not protons. Okay, because if you gain or lost protons, you would not have the same element. Like if sodium lost 1 proton, it would not be sodium anymore. Okay, now on to doing ionic compounds, their names and formulas. Again, this is going to be in methods, and you're not going to be using the same procedure as the covalents. So again, we're going to start with binary. That means you just have 2 elements. So binaries will have a electrically positive metal ion, an electrically negative non-metal ion. First we're going to do formulas to names, and then we'll do names to formulas, and you'll see why. So these can be a tiny bit like binary covalent. Is that they'll have 2 names. They'll have a beginning name and a second name, and they will end in "ide." Okay, but ionic compounds will not use prefixes. Okay, naming them is quite simple. So let's go over some. So this is MgCl2. To name them, it's simple. You just name what element, what metal is in them, and then what non-metal is in them, and it ends with "ide." Okay. So it's going to be magnesium chloride. Right. FeCl3, same thing. You name who's in it. You don't have to tell me how many. So it's iron chloride. NaCl, simply sodium chloride. Al2O3, aluminum oxide. Okay, so they get ides, and ides were found in binary covalents as well. Now, the ides, how you figure out the ides is usually they have 2 syllables. So oxygen becomes oxide, nitrogen becomes nitride. So you have oxide, nitride, fluoride, chloride, iodide, bromide, sulfide, phosphide. Those are typical hydride. Those are typically kind of names you'll get. One thing to notice is that the names give you no indication of how many of each of the element. Okay. So going from formula names is easy, but going the other way, because the names don't give you the number, it's hard. Notice these all in chloride, but they have different numbers of chlorides. So now we're going to do names to formulas. Finding a formula. Right, now like I said, the name doesn't help much. Just tells the type of element, but not how many. So how do we determine the number of each element? Well, what we need to know is what is the most common ion for the elements. So ionic compounds are made out of ions, and the ion, each element will have its own common charge to it. It will have its own common net charge. And this is the part where you're going to have to memorize. Okay, so I said you can't memorize the whole molecule, the whole ionic compound, but you're going to have to memorize the parts. So the first column, metals. Metals will always have positive charges. Non-metals will have negative charges. So first column will always have a 1 plus charge, and we leave off the 1. So everything in the first column will have a plus 1 plus. Now, a 1 plus. Now 1 plus is different than plus 1. It means 1 plus, 1 positive charge. Right. So don't write, plus 1. It's 1 plus, or 2 plus, or 3 plus. Right. The second column, guess what? It gets 2 plus. So magnesium, calcium, beryllium, and so forth, all will get a 2 plus. So if you hear anything from the first column, automatically write down its symbol and give it a plus sign. And anything from the second column, write down its symbol and give it a 2 plus sign. And then there will be 6 other guys I told you, and these you're going to have to commit to memory. Okay, there's no easy way to help memorize them. You just got to memorize them. All right, so they're right in front of you here. So forgot to put on my pointer. Okay, so again, so I'm waving around. So again, so sodium, everything in the first column gets plus, second columns get 2 plus. All right, and then you get these 6 guys in the middle, and lead a little bit on the outside. Just got to memorize. Copper's 2 plus, iron 3 plus, aluminum 3 plus, zinc 2 plus, Bb 2 plus, Ag plus. Right. I'll do common charge of the negatives, of the nonmetals. Okay. The 17th column, so you have the very last column is the 18th column. You will not find those in any compounds. They're called noble gas. Right, going from right to left, the 17th column, everything in that column gets a 1 minus. So F minus, Cl minus, Br minus, and so forth. The column next to that, to the left, gets 2 minus. O2 minus, S2 minus, and so forth. And the column left of that gets 3 minus. And the column left of that gets 4 minus. So the metals going from left to right get larger positive numbers, sort of like a number line. And the nonmetals get bigger negative numbers going from right to left, sort of like a number line. Okay, so here you go, the rhyme and reason behind it. It's interesting that certain rows have such the same charge. Why is this? It's because we'll get into this more later on in the semester, but it has to do with the chemical property. So everything in this first column have a chemical property of having a 1 plus net charge as an ion. Right? Everything in this column has a 2 plus charge. That's a chemical property, as everything in this column has 2 plus charge. But in the middle, it doesn't, it doesn't go 3 plus, 4 plus all the way across. It gets messy in here. And so we're just having you memorize a few of these guys. So I left off lead down here, but said lead is 2 plus as well. So, and then the nonmetals, they get 1 minus, 2 minus, 3 minus, 4 minus. Again, numbers get bigger, moving right to left. And 1 plus, 2 plus. All right, so we have our basic starting points. So now what we can do is apply this. So let's try magnesium chloride. So I'm going to give you a name, magnesium chloride. What you have to tell me is the chemical formula. And we know it already from previous slides. It should be MgCl2. Now let's see why it is. So magnesium is a metal, so it gets a positive charge, and it's in column 2, so it gets a 2 plus charge. So what you do is write out Mg2 plus. Chlorine is a nonmetal, so it gets a negative charge, and it's in the 17th column, so it gets a 1 minus charge. So you write that up. So this is your starting point. Now, what you want to do is you want to have the same amount of negative charge as positive charge. But what you can't do is you can't change these numbers. I can't change this to 2 and this to a 1. What I have to do is either add, and maybe sometimes subtract, elements from my what I have. So I have Mg2 plus and only 1 minus. So so what I need to do, I have to add another Cl minus. Okay, so I have this Mg2 plus, one of them, and Cl1 minus, and 2 of them. So this 2 means that I have 2 of them. And that's your chemical formula. That's it. And you notice it's exactly what we have. You can get rid of the 1s, and then you get Mg2 plus Cl2. You can get rid of the parentheses too if you like, and just have Mg2 up. Leave the charges on. Okay, don't take away the charges. We're going to be using the charges when we get into chemical reactions. Right, let's do another one. Aluminum oxide. We know the answer already from previous slide was Al2O3. So let's see why. So aluminum is a metal. Okay, ends in Um. Okay, if you go to England, it would end with IUM. So it gets positive charge, and it's one you have to memorize, and has a 3 plus charge. Oxygen's non-metal. It's found in 16 column, and everything in 16 column gets 2 minus. So aluminum goes first and the oxygen second. So we have our Al3 2 minus. Now this one's a little bit more difficult. You just can't add 1 to figure this out, because if you add another O here, it's still not 3. So you have to manipulate it a bit. So what you end up having to do is have 2 Al3s and 3 O2 minuses. Okay. So now the charges balance out. You have 6 pluses and 6 minuses. So to shorten that, you have 2 Al3s and 3 O2 minuses. Okay, and get rid of the parentheses, and you have Al2O3. Okay, and that's exactly what. Again, don't leave the charges off. You can remove the parentheses. All right, so the key to this is to write out the element and its charge, then balance the charges. Now this one took a little bit of effort to figure out, but the first one didn't. You just had to add another chlorine. What I'm going to do now is help you figure out a method to quick method to figure out these subscripts, and it's called quick and dirty. And often in chemistry, a lot of times in chemistry, there's quick ways to come up with an answer without figuring it out, without doing it like we just did, trying to figure out how many oxygens and aluminums by balancing charges. Okay, so the way you do it is we're going to use something called the crisscross method, but you start out with the same starting point. Okay, so Mg2 plus a 1 minus. Right, now what you do is you take the number 2 and the number 1, not the charges, and you crisscross it. So you move the 2 over here and the 1 over here. And so you have Mg2 plus 1 Cl1 minus. And there's your answer. Okay, so it was a quick way to come up with the answer just by crisscross. Now this isn't a why, it's just a method. Okay, it doesn't tell you why it happens, it's just a way of doing it. So now let's do aluminum oxide. So aluminum gets an Al3 plus, and oxygen gets a 2 minus. So you have Al3 plus, O2 minus. Move the 3 next to the oxygen, and the 2 next to the aluminum, and you get your answer. Okay, now this method does have a problem. It doesn't work all the time. So let's take a look at magnesium oxide. So magnesium is 2 plus, oxygen is 2 minus, and so you get Mg2 plus and 2 minus your starting point. If you crisscross, you get 2 and a 2, which is incorrect, because what you want to do is have the lowest common denominator between them, whole number ratio. So you'd have to divide both of these by 2, because 1 is lower than 2. So if the charges are the same, you just leave it. So this answer is MgO. If the charges are the same, do not crisscross. Another thing, don't move the charge with the number. So just move the 3 and the 2. Okay, so that finishes binary ionic compounds. Right, the last section is the tertiary ionic compounds. These have 3 elements. One of the elements will be a metal. The other 2 elements will be found in a polyatomic ion. So I told you to really memorize the polyatomic ions. Okay, they're anions. They have negative charge. All right. So we're going to use. So remember that they all end in 8 except for hydroxide. So all of these guys will have a metal and a polyatomic ion. All right. So let's go over, and we're going to do naming first. So formula to name, and then name the formula. So let's go over this guy here, NaCO3, Na2CO3. All right, first of all, you want to know if it's ionic. It's ionic because it has sodium in it. Okay, it has a metal. It's tertiary because it has 3 elements, as Na, C, and O. So if it's tertiary, that means it has a polyatomic in it. Right, so the name is going to be sodium carbonate. So you don't have to tell how many sodiums in it. Carbonate is always CO3. A lot of times I put a circle around a CO3 just to show you that it's a whole thing. Okay, Fe2SO4 Okay, it's ionic because it has iron in it. It's tertiary because it has 3 elements, Fe, S, and O. This part here is a polyatomic called sulfate. So the name is aluminum sulfate. And it has 3 sulfates, but we don't have to tell that. Then finally you have sodium, and then you have hydroxide, metal, and then polyatomic. Okay, all of them have 3 elements, 1 metal, and then 2 elements from a polyatomic. All right, so now we're going to go the other way, and it's going to be very similar to what we just did. Okay, so finding the formulas again is similar to binary. Given the name, write the element in the polyatomic ion with charged and balanced charges as before. So let's do sodium phosphate. So you write sodium with the plus charge, and then phosphate's PO4 3 minus. And then what you do is you crisscross the charges. You put the there's a 1 in front of here, so you bring a 1 over here, and you bring a 3 over here. So this is the formula: Na3, Na plus 3 of them, PO4 3 minus. So that 3 minus belongs to this whole thing. All right, and another example: barium phosphate. So write barium, it's found in the second column, so it's 2 plus. Phosphate is PO4 3 minus. All right, so I'm going to bring the 3 here and a 2 here. So I have Ba3 PO4 2. And that's barium phosphate. Okay, so just take a practice. It's going to have to take practice. Now notice one thing about these: they end in 8. So tertiary, except for the hydroxide. Most of these tertiary ionic compounds end in 8. You're going to have to memorize the polyatomics, to really spend a lot of time with that, okay? Crisscross charges, and you will get done. Okay. So, okay, we're nearing the end here. It's almost 2 hours. And I'll tell you how to maybe break this up into half-hour segments or so. So you take I've been just sitting down here for 2 hours just doing this all at one shot. So I'm getting pretty sore in my throat, but I had to do it. And I'll try to help you set it up so it's a way you can compartmentalize it. All right. Okay, so let's say I give you a chemical formula or a chemical name, and I want you to find out its name or formula. Okay, the first thing you always need to do is what you really should do is kind of think first. So let's say I give you a name like NaCl. All right, formula NaCl, and I ask you. I want you to give me the name. Now, if you were to do this in a real systematic way, the way I would do it is, first of all, determine if it's ionic or covalent. And the way to do that is listen to the name, sodium chloride. Okay. One of the things about ionic compounds will always have two names. Just two names. So, but the covalents can have one or two names. So, right off the bat, it has two names, so it could be either ionic or covalent. All right. So sodium. So next you would do is you would check for sodium and see if it's a metal. Right. So, and one way I told you by listening to the name, if it's a metal, is if it ends in IUM. And sodium ends in with IUM, and therefore you have a ionic compound. Right. Next thing you want to do is determine if it's binary or tertiary. Okay. The binaries will end in "ide," and the tertiaries will usually end in "ate" unless it's hydroxide. So sodium chloride tells you it's binary. Okay. So then when you figure out, you write down Na plus, because it's found in the first column, Cl minus because it's in the 17th column, crisscross charges. They have the same charge, 1, so you don't have to crisscross, so the answer is NaCl. All right, so let's do another example. Let's say I tell you C2H6, and I want to know what it is. First of all, is it covalent or ionic? So C2H6. Well, first thing to do is look at the first element, C, and see if it's a metal. If it's a metal, it's ionic. If it's not, it's covalent. So you're just going to have to look at the periodic table. So remember, the only metals that we're going to use are the first two columns and then those 6 in the middle. So if you notice, C, carbon, is not in the first two columns or those 6. So this has got to be covalent. So it's got to be one of our 5 categories here. All right, and this is where the numbering comes in. So I have C2H6. So first thing I do is I go, is that a common? Well, I remember I memorized those 5 and go, no, it's not one of those 5. Next thing I do is I go and check to see if it's alkane. Right. So the C2H6 and alkane. Well, what's common between alkanes? Chemical formula. They all have carbons and they all have hydrogens. Okay, well, C2H6 falls into that category. So it's probably going to be alkane. Then you would go into your alkanes and pick it out. Okay, it's the second one. It's ethane. Okay, so that's how we would do these things. If, let's say I give you PO43 minus. Okay, check to see if phosphorus is a metal or non-metal. you find out that it's a nonmetal. So it's got to be one of these 5 categories. Is it a common? No. Okay, it's not one of those 5. PO4 3 minus. Is it alkane? No, because it's just not carbons and hydrogens. Okay, is it an acid? So that's the 3rd category. No, it's not acid, because acids have H in front. Is that polyatomic? Yes. Okay, it's one of those 5. PO4 3 minus phosphate. All right, one more. Let's say I have SO2. Okay, and I want to know its name. So first thing I would do is see if the S is metal or non-metal. Well, S is not in the first column or in the second column or one of those 6, so it's got to be covalent. So it's going to be one of these 5. So first thing I do is I check it out to see if it's common. SO2 is not one of my 5. Okay, is it an alkane? No, it's not an alkane, because alkanes have carbons and hydrogens. Is it an acid? No, because it doesn't have an H in front. Is it polyatomic? No, because a polyatomic has negative charge on it. So it's got to be a binary. So you just name who's in it and how many using prefixes. So sulfur dioxide. So the first element, if it's just one of them, you don't do mono. All right, we're finishing it up here. Okay, this is a lot of stuff. What I would suggest you doing is make sure you go over the ionic compounds and make sure you see what I do. I'm going to send out some worksheets and maybe I'll make another PowerPoint of doing some ionic compounds and some more naming, just like I would in class, so that you can get some practice. But for the covalence, you use the Quizlet. For the ionic compound, I have a program that I'll give you the link and show you how to use it in the next PowerPoint, which will just be auxiliary to this PowerPoint to help you with it. The naming and formula names and formulas are really the most important thing from this, going to be for your first test. So let me just go over some helpers, and like I said, what I'll do is I'll do another PowerPoint of some practice problems so that you can see some more examples of it, and then give you some links to help you work on it. So, okay, some helping things. So if you have ionic compounds, they'll always have a metal. Okay, and remember the metals will be in the first 2 columns or those 6. So we have to memorize that. Binaries will end in "ide", and tertiaries will end in "ate", except for hydroxide. They will not use prefixes in their names. You have to figure their formulas out. You can't memorize them. Covalent compounds, the commons, you just have to memorize. The alkanes, names end in "ane". It just has carbons and hydrogens. The number of carbons is in the name, usually, like pent, hex, and whatever, except we have our little trick with the MEPB, meat eaters prefer beef. And there's a ratio of carbons and hydrogens. But if you just start with methane, you can figure out the other guys. So methane is CH4, ethane is C2H6. So every time you add 1 carbon, you add 2 hydrogen. Acids, well, the name gives it away. They always end in acid. Then they always start with an H, the chemical formulas. The binaries have hydro in their name. The tertiaries don't. The binaries just have 2 elements. They have an H and an element from the 17th column. The tertiaries will have a polyatomic ion in them. And the number of H's is equal to the charge of the polyatomic ion. Polyatomic ions end in 8, except for hydroxide. They have oxygen in them. Their name tells you what other element it has in them, like phosphate has phosphorus. And they have negative charges. And you got to memorize those guys. I gave you a little trick that maybe help you memorize the pattern. Like a carbon and nitrogen are in the same row, and both those have O3s, and phosphorus and sulfur are in the same row, and they get O4s. Binary covalents are the only ones that use prefix. Well, alkanes do too, I guess, but these ones you'll be using them all over the place. Dis, tris, and so you're going to have to memorize the prefixes: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. The last 6, penta, hexa, hepta, octa, nona, and deca, are found in the alkanes as well. But mono, di, tri, and tetra are not. And again, do not figure out the formulas of the covalent. You have to memorize them. The only covalent compound with a charge is polyatomics. And just don't fling charges around. Don't use charges at all with covalents. All right. All right. So here's a list of the vocabulary that I want you to know. And so I gave you a link, and I'll give you this link in in Blackboard as well. And I will give you a link to the covalent molecule flashcards. And I'll do another PowerPoint helping you go over names and formulas again, and probably the next couple days. Okay, so there's a lot here. This is 2 hours, and I'll explain in the announcements how you probably want to break it up so that it's not no one could stand listening to me for 2 hours. I couldn't either. So you may want to break it up into 20 minutes sections or so. But I'll try to give you a kind of organized way to go about doing it. Okay. Good luck, and just move on from here. Thanks.